All right, recording has started. Good morning. Today is Monday, October the 25th. We are on day number 2 of Parabolas 3.08. Don't forget that you can download the guided notes from the course contents. Just go to 3.08. There will be a new section called guided notes, and you can download the 3 PDFs, one for each day of this section. This will allow you to have these notes already there for you, and you can print them out and work through them that way. All right, everyone, what is the answer to the bell work? All right, looks like everyone that is here got it correct. The answer is A. This one was pretty easy, right? So why was this one so easy? Other than that, it was multiple choice. What was the giveaway? Let's see. The vertex coordinate. Yeah, yeah. The direction and the vertex. Choice A. That was choice A. Every problem is very different, right? So if you pulled out the vertex properly, only one of these choices has the correct vertex, which is 1 comma -4. So 1 comma -4 is right there. So there's the vertex. Yeah, and this is the only one that actually has the correct vertex. But we also know the direction is to the left. Also another giveaway, and we know it's to the left, remember, because of this right here. This is the negative x direction, so to the left. So B and D are the worst choices. I'm so happy none of you chose B or D, because those are absolutely the worst choices based on the direction. The only true good guesses would have been A or C if you had no idea what was going on after that. But A has the correct vertex, and then you can see that there's the rest of the information there. I actually meant to cover up those choices and only actually had the graph as the options, but it's all right. Okay, equations of parabolas. This is not too bad. Uh, just quick review, just like the first day of parabolas, we have the different parts. You have your directrix, your vertex, your focus points. Don't forget your arrows, right? So, oops, arrow here. On this page, same thing. We have the arrows. There's your focus point. Just draw it in there for fun. There's the equations, and remember this right here, this focus, this point right here is h comma k plus p. This only applies when it's a positive vertical equation, because if this was a negative 4p, it'd be opening down, which means you have to travel down a distance of p, not up. So hopefully that is clear when you're looking at the actual formulas. This is only applies to, well, opening up. Opening down, it would be k minus p, of course. And we did talk about that last week. Same thing for this. We have the, oops, don't forget your arrows. And then, let's say here's your focus point right here. And this is a positive horizontal equation, so it opens to the right. So this formula right here, this h plus p, only applies when it's opening to the right. So if that was opening to the left, it would be h minus p. And again, we did talk about that last week, and just like the directrix, the directrix line, like you see over here, is h minus p, but if it was opening to the left, it would just flip-flop the sign. We all know that already. All right, I want to also point out, see if I have another page here. Let's see. Nope. Okay, point out again. I'm going to use green. My mouse is freaking out. So the distance, actually, I'll use blue. The distance from your vertex to your focus, what is that distance again? Yeah, that's a distance of p. Okay. And then I'm going to use a different color. The distance from your vertex to your, one second, 1, 2. All right, this doesn't look like it's to scale, but that's all right. The distance from your vertex to your directrix line, which it does look like it's actually not to scale and it's off, but that's fine. What is that distance? Yeah, it's also a distance of p, right? So I just review that from the vertex to either your focus or vertex to your directrix is a distance of p. All right. There's the equations again, and don't forget that this number out in front, this is 4p. So whatever number is here, to get your p value, you have to divide by 4, of course. And there's the example we did last week. All right, let's get into this. All right, we want to find the equation of a parabola in standard form given the vertex is -9, 7, and the focus is -9, 3. So, how should we maybe approach this? It's a good way to start this problem. So determine if it's vertical or horizontal. Yeah, and how can we determine that, Isabella, or anybody? Yeah, the value changes. So if you were on your own on this problem, what would you do for this problem to kind of help you keep everything organized and straight in your head? Yeah, plot the points or draw a rough sketch. And that's what I do every single time, whether we're talking about circles, ellipses, hyperbolas, or parabolas. So we are given the vertex. So let's go -9, 7. And you don't have to plot these exactly on a graph. They don't have to be accurate. We just have to say, here's my points, -9, 7. All right. And then let's plot my other point, -9, 3. Now, in relation to my first point, which direction should I travel to plot my focus? Anybody else want to agree with Enzo or disagree? Isabel says same thing. Yeah. Yeah. So we want to travel down to go to the focus. So here's my here's my vertex, which is -9, 7, and my focus is -9, 3. So the x value stays the same. So we're not traveling left or right. The y value is different, and it is smaller than the 7. So we are definitely going to travel down to get to my focus point. So on my paper, I would plot those points like that just to keep it organized, and it really shows me where's my vertex, where's my focus, and then I can just do something like this to show that, hey, because of that, we know it opens down, right? So in my final answer, in the answer here, we're going to have something squared equals some number, um, just like that. All right, now based on our little sketch here, on the information we were given, um, what variable goes here? Yeah, what variable goes here? Yeah, the y variable does. Yeah, the y variable goes here, which means the x has to go over here. Now, will the number out in front, based on our little sketch, will this number be positive or negative? It'll be negative. Yeah, because it opens down. All right. All right. So this tells us our parabola opens in the negative y direction. So it opens down. And I see a lot of you in chat had already put down what these are. What is the vertex? So, well, actually, it tells us the vertex is this, right? -9, 7. All right. So what number goes right here next to the x? A +9. And what number goes next to the y? Yep, -7 or -7. So we're going to fill that in too. So we have x +9 here, and then we're going to have the y -7. So far, this is pretty easy, it seems. So we need to figure out one more thing, which is the number that's right here. How can I find this number? Let's do this. How about I give all of you 30 seconds to find that number? Everyone do it by themselves and see if we can get everyone get the same thing. So let's do 30 seconds. Ready, go. All right. What did all of you get for your p-value? What's p equal? So a lot of you say p equals 4. So what number goes right here then? Yeah, very good. Yeah, -16. So again, just to show what I showed earlier, is the distance from your vertex to your focus, that is a distance of p. And so your p-value is, we use the distance formula, and we only care about the distance in the y direction. If you want to use the full coordinate form of the distance formula, knock yourself out. But just like hyperbolas, we can kind of forego pretty much half of that formula and just focus on the y coordinates. So it's the distance from 7 to 3. So I can either do 3 minus 7 or 7 minus 3. It doesn't matter. So 3 minus 7 or 7 minus 3. So in this case, I get -4, which is +4 there. So the p-value is 4. Now, don't forget this number right here, right? This number is 4p. And our p-value is 4. So we have to do 4 times the, well, 4, which all of you did in chat. And that's how you got 16. And we just plug 16. So that's why is a -16 in front of that binomial. And that's the answer we get. Yeah, not too bad. All right, let me have all of you try this one all by yourself. So I'm going to give all of you 3 minutes. 3 minutes for number 2. Ready, go. And then when you are done, just give me the green check that I will throw up on the screen here in a minute. Right, everyone is finished. What is your final answer for this one? Y minus 5 squared equals -20 times x minus 2. Anybody else? The rest of you are probably trying to type it out. It looks like those two already had it typed in when I asked that. So Lizette says same thing. Same as Brady. Looks like everyone got the same answer. So let me show that. You got that. Hey, Bentley. Who got this answer correct? Ooh, I'm sorry. Yeah, everyone got it right. Nice job, everyone. So it looks like I can skip this one, but just like the last problem, we would want to plot some points. Now, I will plot the points, kind of show how I would have approached it for those of you watching the recording later. So the vertex is 2, 5. I'll just put that right here. And then the focus is -3, 5. So the x direction is what is changing. So I didn't trick anybody, which is nice. And -3, 5 is the focus. So that is over here to the left. So there is your focus. There is your vertex. And just plotting those things, we can see that this opens to the left. And showing this, is why it is a negative x direction. So perfect, everyone who got this one right, which is everyone here. And then from here, you can easily find the p-value, the distance. All right, number 3, a little different. This one says, what is the equation of a parabola in standard form given the directrix is y equals -6 and the focus is -7 comma -2? All right, a little different, but we would still want to approach it the same. So do a rough sketch of what is given to show us what is going on in this problem to really, push us in the right direction. So I'm going to give all of you 3 minutes again. I will put the polling. So once you finish this one, we will go ahead and proceed. So 3 minutes, see what you can do. Isaiah, you still with us? All right. What did everyone get for their answer? Ooh, x plus 7 equals 8 times y plus 4. Two people said that. Hmm. Forgot the square. Yeah, if you forget the square in a TGA, I will mark it wrong. All right, Brady, fair enough. All right, so yeah, I think that is the correct answer. So who got this one correct? All right, looks like it's kind of split. Um, three of you got it, and then two of you almost got it. It looks like. So let's go through it and kind of figure out where we could have made a mistake. All right, how did all of you start this problem on your paper? What did you do first? Yeah, plotted the points. Plotted the points of what's given to us. So we have the directrix at y equals -6. Now, is that going to be a vertical or a horizontal line? Yeah, it's a horizontal line. So, let's start by doing that. All right, so y equals -6. So I'm just going to do just some horizontal line just to show that. Okay, so there's your directrix. And it gives you the focus being -7 comma -2. So is that point going to be above or below that horizontal line? Yeah, it's going to be above it. And we know that because the y value is -2. This y value is -6. -6 is less than -2. So it makes sense that this point should be somewhere above this line. So I'm just going to put the point right here. It really doesn't matter. So that is your focus. I'm just put an F next to it to show it's the focus point. All right. Now, is this parabola opening up or down based on what we have there? Yeah, it's up. So my equation here is going to be something squared. Euro is super laggy this morning. All right, so because it opens up, what variable goes here? Yeah, the y variable. And it opens up, so is this number out here going to be positive or negative? Positive. And yes, we can all see the answer, but I still want to kind of reason through all of this still, just for those that need to see it or want to see it. So that means y goes here, which means x goes here. All right. Can we put both of these numbers here yet? No, not quite. Because this is the focus. So how do I find the vertex? So the vertex is directly in between the directrix and the focus. Yes. So I'm going to go ahead and just show that on our graph. It's somewhere between. So there's your vertex. So it opens up. We already said that. And the distance from vertex to focus or vertex to directrix is the same. So how do I find this coordinate? Yeah, it's well, sort of Enzo. So it looks like, based on what you're saying in chat, a lot of you kind of chose the longer route to find that coordinate, and that's okay. So how do I find the point between the directrix and the vertex? So a lot of you are describing a kind of a longer route to get there. Yeah, so you can count. It might work out that way, but I'm kind of looking for a specific answer. So we all said that the vertex is right in the middle of the directrix and your focus. So it's in the middle. So if I want to find the coordinate that is the midpoint of the focus and your directrix, I should use what formula? The midpoint formula. Yes. Is that longer? Let's find out. Let's find out. Now let me ask you this. Do we already know one of the values in our ordered pair? Do we already know one of them? Yes. Yes, we know which one. The -7, because if you know the x value, focus, vertex, directrix, whatever these points are, the x value is the same, and the x value of your focus is -7. So right away, I can fill in this right here. We already know what the x value is of the vertex. So in your formula, your midpoint formula, hopefully you have a sheet that has all the formulas. The midpoint formula, again, remember, is your, I think it's what, x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So that's the formula, I think. We don't have to find the x piece. We can ignore this part because we already know it's -7. There's no reason to plug stuff in to show what we already know. So we just got to do the y stuff. We got to find the midpoint between the focus and your directrix. So we're going to do that. So we have, the x stuff already. Your y value for your focus we know is -2. We know the y value for this point on your directrix line. We know that that y value is -6. We don't care what the x value is. It's the same thing as the focus, so I'm just not going to write it. So I put -6 here. And then -2 plus -6 is -8. And then -8 divided by 2 is going to be equal to -4. So the vertex, that coordinate we know is the x, which is -7, comma, and the y value we found was -4. It is not the same thing. So let me kind of explain why. A lot of you in chat, and maybe I missed someone who actually stated it right. So I apologize if you did say it, but I didn't see it. A lot of you were saying you're just going to find the distance and divide by 2. Well, that's not true, because the distance between the directrix -6 and -2, you would subtract. You would say -6 minus -2 divided by you would divide by anything actually. You just do -6 minus -2. So, and the absolute value of that. So the distance is 4. Again, when you do that formula, you're finding the distance from here to here, which is a distance of 4. And if you cut that in half, you're finding the distance of just 2, half the distance. This is not the same as actually finding a coordinate. They seem the same, but in the midpoint formula, you are adding. When you find distance, you are subtracting. You see how that little piece makes it very different? And if you mix them up, you're going to have wrong answers left and right. So I would recommend having your formulas on some sheet, and you should have your distance formula, and then maybe right below it have your midpoint formula. That way you can actually look at it so you don't mess up those signs. Because if you change it to a plus or a minus when it should have been the other one, your answer is going to be wrong. And this actually gives us the coordinate, not a distance. So we know right away that that is -4. My guess is a lot of you, when you work this out by yourself to get this answer, you probably found the distance and then you cut it in half to find just the p-value. And then from maybe the focus, you just subtracted the p-value to get down to, well, -4, right? Is that how a lot of you did it? Yeah, and that's okay. And that is okay. Or maybe you started at the directrix and you added p to get to the coordinate. You know, same idea, just different starting point. Or maybe you actually plotted these points and you just saw it visually of where it should be, and that's how you did. And that's okay too. And that works for problems where numbers are really nice and you don't have radicals, you don't have decimals, and everything kind of fits on your graph. Like what if your focus and your directrix, or your focus and your vertex was like more than 200 units away? Are you going to count 200 boxes, for example? Not saying that I would do that, but that is a possibility that could happen. But yeah, so we now have that coordinate, and we can just fill that in, which we're going to have y plus 4, just like the answer shows. And then lastly, we do need to know the your p-value, right? Because we need to find what 4 times p is. There's two ways you could have done it. You could have found the distance from your focus to your directrix, find that distance, and then divide by 2, and you would have p. Or we could have used our newly found vertex coordinate along with this focus coordinate and just found the distance from point to point, and it got your p-value. There's really two ways to do it. I'm going to use the distance formula and then cut it in half from focus to directrix. So that is going to be, so our p-value in this case is going to be the distance between those 2 points divided by 2. So from, remember, this is the y, so from -2 minus our -6. Should have left more room for myself. Which then equals, in the numerator, we have -2 minus -6. This becomes a plus. So -2 plus 6 gives us a positive 4. And then the absolute value of 4 is obviously 4 divided by 2. So our p-value is 2. And remember, this value right here is 4 times p. So we just take that that 4 and multiply it by our p-value, and then that's how we get 8. And like a lot of these problems, there's different ways you can approach them. This is just showing one of the possible ways. Yeah. All right. Let's try. Let's try this one. All right. We'll do 3 minutes again, and I will put the polling on the screen here in about a minute. And when you're all done, just hit the green check. Ready to go. All right. What's your final answer, everyone? Ooh, nobody made the mistake I was expecting. And you all simplified. Very good. Nicely done. Nicely done. Who got this one correct? So almost everyone. All right, let me quickly just draw a diagram to kind of show this, and then from there you should be able to figure it out. So this one gives you a directrix, and it gives you the focus, kind of similar to the other one. This is a vertical line at x equals -5, so we'll just do a vertical line, and then We have a focus at 5, -7. So the x value is changing, and you all should have plotted your focus right here. So that is the focus, which means the vertex is smack in the middle. So it definitely opens to the right. And then all of you could have found the different coordinates. So you could use the midpoint formula to go from here. Remember, this is just the x direction. We already know the y value uh, of this coordinate, which is the same as the focus, which is -7. So you just had to use the midpoint formula to find um, from the focus to the directrix. So from -5 to 5, and really you can just look at -5 to 5. The midpoint between -5 and 5 is definitely 0. So without even showing any work, maybe some of you reasoned through that without actually showing that -5 plus 5 divided by 2 is equal to 0. But if you wrote that, that's fine. You should have got 0 for your vertex. And for this piece right here, which you would have x minus 0, and we all know to simplify, so nobody should have wrote x minus 0, which in chat none of you did. You actually just wrote x, which is very good, and you found this value. Maybe your distance p from here to here. Well, that's also really easy because we know that the entire distance is 10. From -5 to 5 is a distance of 10. Half of 10 is 5. So you should have easily been able to kind of reason through a lot of this stuff without showing work, and maybe just put work on your diagram here, and that's 5. And then 5 times 4 is 20. So relatively straightforward, I think, for this one. All right, let's try a harder one, which I don't really know if this is going to be harder, just different. All right, so this one says, what is the equation of a parabola in centered form given the directrix is x equals -4 and the vertex is 3 comma -2? Let me see what the other one looks like. Okay, nothing. Yeah, let's do this one. All right, ready, go. Let me know when you are all ready to proceed. All right, what is your final answer for this one? All right, looks like all of you are agreeing with Enzo's answer. I'm pretty sure Enzo is wrong. And then Isabella has something a little different. All right, Isabella is correct. Right, who got that one correct? Ooh, only one of you got it right. We definitely probably should go through this problem then. Oh, two of you got it right. Definitely should go through this problem together. And maybe you miss it because you just went too fast. You know, it's always a possibility. All right, let's take a look. All right, so the directrix is negative, x equals -4, so we know it's a vertical line. So all of you got that part right. It was really your p-value is wrong, I think. But let's go ahead and just plot vertical line just to show it. And that's at x equals -4, and then the vertex is at 3, -2. And this is going to be to the right. So that is your vertex. Did all of you treat that as a focus point? Is that maybe why you missed it? Some say yes, some say no. Oh, yes. So it's like half of you say that's the reason why you missed it, because you misread it and you treated it as the last problem, which was a focus, not a vertex. Yeah, so that's your vertex. That's the given, which means your focus is over here. So it definitely opens to the right. So yeah, that's the given vertex. So that's, we all should have easily picked out this part, -3 and a 2 here. Remember, the distance from your directrix to your vertex is your p-value. We don't need to figure out what the focus is. We could just find that distance. So your p-value distance is the absolute value of one x minus the other x. So we have the vertex x is 3, the directrix x value is -4. And so we have 3 plus 4. So 3 plus 4 gives us 7. And the absolute value of 7 is, well, 7. And then to find that number in front, remember we have to do 4 times p, which is 4 times 7, which gives us 28. So what was the mistake that a lot of you made? Like, how did you get 14? You mixed up x and y. Okay. So I'm guessing when you found like this distance, you did -4 and you used this -2 value. Is that right? So -4. No, that still wouldn't make sense of why you got that. Yeah, I'm not really sure. We treated the vertex as a focus and divided it by 2. Yeah, I could see. Yep, that would be how you could get 14 instead of 28. So yeah, you got to be careful. So this one gives you vertex, and that's why you want to label your stuff like I did here. There's your focus point, but remember your p-value is directrix to your vertex or vertex to your focus. So don't really care about that. That's just extra stuff if we really wanted to find that. This previous problem, it gave you the focus. this one gave you the vertex. So really, this problem was actually easier than the last problem. There was far less work needed. All right, we are over time, so you have to go to a different class. That's fine. Since I don't have a class after this, I'm going to go ahead and finish this with all of you that are still here. So let's finish this last one, and we'll call it a day. So number 6. Let's see if we all can get this one correct. What is the equation of a parabola in standard form given the directrix is y equals 0 and the vertex is 6 comma negative 3? So let me know when all of you are done with this one, and we will talk about it. Oh, by the way, I always forget to tell this class. I do upload our lessons to YouTube. I did put the link there. This is the playlist for Unit 3. This allows you to kind of really skip around our different lessons that we've had for this unit to easily review stuff without actually downloading everything individually. So feel free to bookmark this or subscribe so you're notified when I upload the new lessons, which I try to do it daily after the lesson in the afternoon when I have time. So all of you are done. Let's take a look at the answer. So Enzo got a negative direction. Brady got a positive direction. Brady, do you want to change your mind about the direction of your parabola? You said you should, but nah. Okay. All right. Let's see who's right then. Well, it is definitely negative. So yeah, negative y. So it opens up down. Yeah, so all of you should have done a horizontal line to show your directrix, and then your it gives you the vertex point as 6 comma negative 3. So this is traveling down underneath it because negative 3 is less than 0. So um, here's your vertex. So this one opens up down. Brady, you see your mistake? Of course, of course. Okay. And then from there, it's pretty simple, right? So from here to here is your p-value, and that's pretty easy to see by the graph that it's a distance of 3. And 3 times 4 gives you 12. And of course, this one gives you the vertex, so you can easily just plug in those numbers accordingly. So not too bad if your rough sketch was accurate, showing that that point was below your directrix and not above it. All right, everyone, we'll go ahead and stop here. As always, thanks for coming, and I hope you learned something. I will see all of you tomorrow for day 3 of Parabolas. All right, have a great rest of your Monday.